We have to go into the last part of the course that we have been discussing, and that was the topic of meta modeling. Keywords are model versus meta model, OMG 4-layer architecture, model versus grammar, UML meta model, and then a particular example for meta modeling, the ER data, the entity relationship data model, the relational data model, the syntax aspects, so the schema aspects, the semantics aspects, the state aspects of each of the data models over here. Okay, so yeah, meta modeling with meta models. So the general claim and what you should have in mind is a meta model is a model of a model, and an instantiation of a meta model gives a model. So when you instantiate a meta model, you go one abstraction layer, one abstraction level down. You go from when you build an instantiation of the meta model, you forget about the meta and you get a model. What does this mean? Let us look at a concrete example. Let us look at this one over here. The example is, this is a meta model and we instantiate it. We get a model, and this model corresponds, these two representations are representations for the same model. This is a view. This is a view for that in form of a class diagram, and this is a view of that in form of an object diagram. So we have here this pattern, model, instantiation of a model, model, instantiation of a model. The trick is that the instantiation of this model is again a model. And the reason why we call this here a meta model is exactly the fact that we take a meta model, we instantiate it, we obtain a model, which again can be instantiated. So, this is what the OMG is also doing. So, what we were doing in the course during the main time, we have been considering user models and then so class diagrams, and we have been building object diagrams. And what we now do in the user model, in our class models, we have been using particular concepts. Namely, we have been using concepts like classes and associations. And what we do in the meta model, in particular in the UML meta model, is that we model the concepts that we are using here in the user model. We are modeling these concepts again as a model, we are modeling concepts as a model, and thus we have a meta model. And so the term or the notion is that this is the UML meta model, because we have concepts here like class, attribute, operation, and so on. And what the OMG does, and the 4-level meta model of the OMG, is that UML in principle is again specified with a subset of UML, and that's my view, the OMG, the Object Management Group, this consortium of IT producers calls this subset of the UML, gave it a particular name, Meta Object Facility MOF. But de facto it is a subset of the UML. So UML is modeled to a large degree with UML itself. And this is the 4-level meta model in the OMG view, and the classical view of in the programming world is as follows. We have one specific Java program J, and then we can execute this program J one time or many times. So we consider one particular execution of this Java program J, as we can consider for one class diagram many object diagrams. So here we have the Java program J, and we consider one execution J. Then for Java, there will be a context-free grammar which describes the programming language Java, but there are also context-free grammars not only for Java but for other programming languages, for example Pascal. So there are a lot of context-free grammars here, and there is a, so to speak, standard. There is a way of writing context-free grammars, and this is called EBNF, Extended Backus-Naur Form. These are particular requirements for writing context-free grammars. And well, these 4 levels of execution of a Java program grammar for Java, and the EBNF specification, these correspond to the 4 levels that are available in the OMG 4-level architecture, and these 4 levels correspond to what we have been discussing so far. More concrete, we have here you see here again these 4 different levels. We have here an object diagram fitting to a class diagram, and now we view this class diagram as an object diagram, and for the object diagram we need to have a class diagram, and then we need to have here a class diagram with classes like association, and a class for class. And then this roughly corresponds to the UML meta model, and we can exactly the same trick that we have been doing here, namely viewing a class model as an object model, that this trick can be repeated. And then we can ask ourselves, what is the class diagram that we need to instantiate this object diagram, and then we end up MOF. And so you see here all levels of the 4 OMG meta model, of the 4-level OMG layers: user objects, user model, UML meta model, MOF meta model, and this is a meta model, and this is a meta model. As a concrete example, we also saw here, in order to meta model this class diagram, you need to have the concept of an attribute. You need to have the concept of a class, you need to have the concept of an association end, you need to have the concept of an association. And in order to represent this class diagram as an object diagram, this meta class diagram, this meta model would be applicable. And this is something like the UML meta model. In reality, the UML meta model is much more complicated. So when we take this class diagram and we want to consider it as an instantiation of the UML meta model, the concrete UML meter model is much more complicated than this simple meter model. The UML meter model part that is needed to model this class diagram as an object diagram is found over here. And there is a use extension. You can load a class diagram, and then there is a plug-in, an extension in use, and you can consider this class diagram as an object diagram, and then automatically the respective class of the meter model, of the UML meter model is computed. But I will not go into the details of the UML meter model. As you see it here, the UML meter model is quite complicated. It is available in use. It is in the use distribution. It is specified in use. It's a rather large model. You see the numbers for classes and associations over here. So I think this is what I wanted to say about the OMG and meter modeling. I want to have some short remarks about the meter modeling of the entity relationship and the relational data model. We have been discussing this example. So this is an entity relationship model. This is the corresponding relational database schema. You can call this an ER database schema. You can call this an entity. This is the ER database schema. This is a relational database schema. This is an ER database state. This is a relational database state. And what we have been doing in this last part was basically all these 4 parts: entity relationship schema, relational database schema, entity relationship state, relational database state. We have been building a class diagram for this. This is a class diagram with which we can model the entity relationship schema, the relational database schema, the entity relationship state, and the relational database state. And the concrete example that we have been considering was so we have had here the entity relationship schema, and in the lower part you see the representation of the ER schema in form of an object diagram. Here we have had the ER state, and in the lower part you see the representation of the entity relationship state in form of an object diagram. Here we have had the relational database schema, the corresponding, represented in form of an object diagram. Here you have elements of the relational database state and how this relational database state is represented as an object diagram. And this object diagram brings together the entity relationship schema, the relational database schema, the entity relationship state, and the relational database state in one big object diagram. We could zoom in, but I will not do so. And for this object diagram, the corresponding class diagram looks like this. And in a quite intuitive way, I have used here part-whole relationships, compositions, or aggregations over there. So, for example, you nicely express here an ER schema consists of entities. An ER schema consists of relationships. A relationship consists of relationship ends and objects. An entity may own, an entity consists of attributes, and relationship consists of attributes, or attributes are the parts of a relationship. Attributes are the parts of an entity, and therefore I've chosen here the part-whole relationships. So at least for the oral examination, this part of this class diagram, you should be able to say some words about this part of the meta model class diagram and how it relates to this concrete example schema. A central ingredient in this course was, of course, to have constraints, and this meta model class diagram has to be restricted by a lot of constraints, and we have also discussed some example constraints. So, for example, just to mention one constraint that within one entity relationship schema, different entities have to have different names. So this is a OCL constraint that is formulating and making precise this textual requirement here. So this means this is a rule when we now extend this ER schema and we build a new entity, we build a new rectangle here, a rectangle that represents an entity, then we cannot have a second entity that is also called person. Yeah, we can call the second entity professor or clerk or whatsoever, but we cannot, when we have here a second entity, when we have a second rectangle, we are not allowed to call the second different entity again person. And this is exactly what is sitting in this constraint here. Unique entity names within ER schema, and this is a formal representation. And this is one constraint for the ER syntax, and analogously there are constraints for the ER semantics, for the ER state part, for the relational syntax part, for the relational semantics part, for the relational state part, and there are also constraints about the transformation. Okay, I think this brings us to the end of what I wanted to say here about meta modeling. So, to say it again, we have 4 main topics for the oral examination. That last topic is meta modeling. That is sort of a minor topic. We have use as a topic, but that is also a minor topic. The 2 major topics for the oral examinations will be UML, and the other main topic will be OCL. And if you are familiar with this, then we will have a nice exam. Okay, just let me go here and say thanks for your attention.